Topic test higher here for the respiratory system. Let's make a start then. So I'm going to just draw your attention to these graphs here. Okay, so we're going to need these three graphs for our first question. So I'm just going to push these over to the right. Bring these forward. Let's just get myself set for this first question. So first thing, then use the graphs opposite. We got them on the page over there. To state the effect of breathing pure oxygen compared to breathing normal air on the volume of gas. So I've put it lowers with pure oxygen. Okay, if we look at this graph, so volume, we got two lines here. Okay, we got this one is for breathing normal. This is for pure oxygen. If I look at the pure oxygen line, can we see that it's lower? We have to breathe in less gas. So for person B, they're only breathing in 80 odd when it's pure compared to 90 when it's not. Person A, then they've got 65 compared to 85. So we have to breathe in less. Question number 2. Person B is a trained athlete. Give 3 pieces of evidence. Now, lactic acid, that thing we produce in anaerobic respiration, is lower in person B. So if we look at that there, lactic acid right down at the bottom, we can see that person B is producing less. Can we see that? We've then got lungs of person B can breathe in more air. They're more trained, and we just looked at that. The volume of person B, which they can get in, is higher. And then finally, person B is producing more carbon dioxide per exhale. In other words, they're respiring at a faster rate. Okay? Now, state the chemical that is changed into lactic acid. Well, lactic acid is anaerobic respiration. And we know that in all respiration, we're converting glucose into energy. Suggest why there is more carbon dioxide present in the lungs when pure oxygen is breathed rather than normal air. Well, the reason for that is we're respiring faster. If I've got more oxygen, more respiration is happening, which means more carbon dioxide is happening. Give a reason for the lower level of lactic acid when pure oxygen is breathed. So if we think more oxygen is so less likely to be forming that anaerobic respiration, that respiration that occurs in the absence of oxygen. So less chance of it occurring if we've got more oxygen. Okay, next page, and we got this diagram. It shows a summary of how glucose is used by different organisms. 1, 2, 3. If we were just looking now, and I'll just label this up, we know glucose gets turned into carbon dioxide and water. That's aerobic. Glucose into lactic acid is anaerobic, okay? And that's for things which are happening in our body. So, question 1, which one does not release energy? Well, glucose is starch. There's no reaction. It's the storage, isn't it? So we've got 2 there, because 2 is glucose to starch. Which one releases the most energy of glucose per molecule? Well, we know that 4, aerobic, is the best. And then finally takes place in yeast without using oxygen. Well, this is called fermentation, okay? So that's question number 3. Move on now. So we're going to look at, the diagram shows side views of the chest cavity. And we've got to look at showing the chest after inspiration. Inspiration now, it's nothing to do with being inspired. It's a posh way, scientific way of saying it, breathing in. Now, so I've got my rib cage there. What 3 things can we see from this? So the first thing is diagram B I have stated shows that it is. And my reasons for that are, first of all, if we look at the lung volume, B is a bit bigger, so there's air in there. 2, our diaphragm is flatter. We know that the diaphragm is flatter when it's inspired, breathing in. See, it's curved there, it's flat there. And finally, our rib cage is moved up and out. Can we see that the rib cage is slightly more down? You can't tell that much of a difference, and it's not as far out. Question B then, we're now looking at an alveolus in the lung. And the dotted line shows the movement of a gas. State what is happening at the point X. Well, we know it's a gas, and we know it goes into the blood. We breathe in oxygen. And it's diffusing, okay? It's diffusing from inside the alveolus into the blood. Explain 2 of the adaptations. Well, the first one is high surface area. If you have a think, it's got all of these pockets. That's got more surface area than just that. And the other thing is moist, okay? And that enables gases to be dissolved, and it speeds up that diffusion. Back to our alveolus now. Diagram shows an alveolus and its blood supply. Complete the label A on the diagram. Well, it's pointing to what an alveolus is connected to, and that is a bronchiole. So let's check spelling on that. Make sure we're spelling these words correctly. And then we've got a 6 marker. Okay. Explain how gas exchange takes place between the alveolus and the blood capillary. Include in your answer a description of how the alveolus is adapted. Okay, so oxygen is diffusing from the alveolus into the bloodstream. Bloodstream carries oxygen away to maintain that gradient. Remember, diffusion is down the concentration gradient from high to low. Carbon dioxide diffuses from the blood into the alveolus, and exhaled here maintains that all-important concentration gradient. Now we've got 2 adaptations to increase this. We have said it's the moist surface and the large surface area. So there's your 6 marker. Pause it if you need to have a look at that. Final question on the paper then. Information heavy, so let's have a read of this. So the following information appeared in a newspaper in Wales in 2010. So we've got some parents who smoke in the car believe it won't affect their health. I'm just paraphrasing it now. We've got stating 1 cigarette, even with the car window, has a greater concentration of secondhand smoke than an evening in a pub or a bar. We've got levels of smoking in cars can be 27 times greater. And finally, young children breathe faster than adults. Their lungs are smaller and they are still growing. Okay, using information from above, explain why the lungs of young people in particular are in danger from breathing in secondhand smoke. So first of all, we've got that they breathe faster than we said that, so they're more likely to breathe in that secondhand smoke. They're also more likely to be around their parents, exposing themselves to the high smoke levels in the car with them. Okay. And also a final one is if we look at the top, parents don't actually think that it affects them. So they could just go on smoking, blissfully ignorant of the damage they may be doing. Final question then. Welsh Government is considering introducing strict new laws. Using the information, suggests 2 other pieces of evidence. Okay. Well, we know that smoking in cars leads to levels 27 times higher. And we know that it leads to higher concentration than pubs or bars. Final question then. State 2 effects cigarette smoke has on the cleaning mechanism. Well, it kills cilia and it leads to bronchitis.